So when we talk about database services, we have different kind of AWS databases that we are going to understand. We'll be understanding about relational versus non-relational database, and we'll be understanding about managed and unmanaged service for the databases. So what are the different database services? The first service that we will be discussing is about RDS. So RDS is a cloud-based database service provided by AWS. It enables us to easily set up, operate, and scale the relational database in the cloud. So why to use RDS? Because we have already discussed that we can get EC2, which is nothing but virtual machine on cloud. So on that virtual machine, I can easily deploy my database. But if I'm deploying my database over there, I will be responsible for managing that. And I do not want that. So that's why we go with Amazon RDS. The next option that we have is Aurora. Now, when we talk about Aurora, it again is the relational database engine which is fully managed by AWS. It is high performance and highly available database which is compatible with just MySQL and Postgres. Okay, now key feature of Amazon Aurora is its ability to replicate data across multiple availability zones within an AWS region. So this provides enhanced durability and availability, making it ideal choice for mission critical applications. Also, it is very fast. We will be discussing about this service in depth in our slides. Then we have Redshift AWS or Amazon Redshift. So when we talk about Redshift, it is cloud-based data warehouse service. Now where are we going to use the warehouses? When we typically do the ETL or ELT systems where we have these processing, extract, transform, load or extract, load, transform, where we are working with data engineering tasks with big data. So at that time we require the data warehouse. So it allows us to store and analyze large amount of data using the standard SQL queries. Redshift is built on columnar storage architecture, which enables it to efficiently handle large amounts of data while providing us with the high query performance. So basically, data warehouse is used when you are doing the data engineering tasks and where you extract the data from multiple sources. So what basically happens is when you are doing data engineering, you would be having multiple sources of data. You would be extracting that data. You would be having some staging tables into which you would be, loading the data. You would be applying some kind of transformations. After these transformations are being applied, you would be finally storing the data into one destination. And that destination is data warehouse. So it would be storing all our structured data, right? So Redshift is a service for data warehousing on AWS. Then the next service that we have is DocumentDB. Again, DocumentDB is fully managed document database service which is being provided by AWS. It is designed to enable user to store, manage and scale semi-structured data. Now what is semi-structured data? Semi-structured data is more flexible than that of the structured data. When we talk about structured data, we think our data to be stored in the rigid schema of rows and columns. When we talk about semi-structured data, we can talk about key value pairs, right? We can talk about JSON document, we can talk about CSV, we can talk about Parquet. These are all the different formats that are being called as semi-structured data. If we want to convert the semi-structured data into the tabular manner, we can, but we actually do not want to because we want some flexibility across the schema. So when we talk about document DB, so it is allowing us to store semi-structured data. It is compatible with MongoDB API. Okay, this is one of the famous semi-structured database. So it is compatible with the MongoDB API, which means that it provides a familiar interface and supports most of MongoDB features, drivers, as well as tools. So if you want to migrate your MongoDB workloads to Document DB without any code changes, then it is possible to do so. The next database is DynamoDB. It is the NoSQL database of AWS. So here the data would be stored, again the semi-structured data would be stored. Okay. So it is a key value and a document database. So it also supports the document, it also supports the key value pairs. So here this database is specifically designed to provide low latency, scalable, reliable storage for web, mobile, gaming, IoT and other application that requires high throughput and low latency for read and write operations. So when you want, millisecond latencies or single digit millisecond latencies, which is, still you can bring it down further to microseconds latency. If you want such kind of applications or you want a database for such kind of application, then you can go with DynamoDB. We are going to discuss this further in our module. Then the other type of database that we have is key space. Amazon Keyspace is basically a fully managed, scalable, and highly available Apache Cassandra compatible database service which is being provided by AWS. So in Amazon Keyspace, a keyspace is a logical namespace that groups together related tables and provides isolation for the data within those tables. So if you want any database which is compatible with Cassandra, and if you want to migrate that to cloud, specifically AWS, then you can use this key space. The next type of database that we are going to discuss about is time stream. Right. So what is this database and how it will be useful for us? So as the name suggests, the time stream, it is designed to enable users to efficiently store and analyze time series data. Now, what can be examples of time series data? The data coming from sensor, any kind of application logs, IoT telemetry data. All of these data are time stream logs. So it can handle the petabyte scale data sets, because we know that when the data is coming from time series or sources such as sensors or application logs, that data would be having a high velocity and the size of data would also be high. So that's why it supports petabyte scale data sets. It provides automatic data retention policies, time series data compression, and query optimization to reduce the storage cost as well as to improve the query performance. And it again provides the SQL-like query language to query our data. You can also query your data in real time. So this was all about time stream. Then we have quantum ledger, right? That is also known as QLDB database of AWS. So when we talk about QLDB, that is Quantum Ledger Database, It is again a fully managed, scalable, cryptographically verifiable ledger database which is being provided by AWS. So it is designed to provide immutable, transparent, and tamper proof ledger that can be used to store data and execute transaction in decentralized and trustful manner. So if you want to have if you want to have a database for tracking all kind of transactions and data history, then you can use this quantum ledger. It is particularly well suited for use cases such as supply chain management, financial services, digital identity, where trust, transparency, and immutability are critical. The last type of database that we are going to talk about is Amazon Neptune. So this again is a fully managed graph database service provided by AWS. It is designed to store and process vast amount of data to highly connected media such as social networks, recommendation engines, fraud detection techniques. So basically, this is a graph database that is optimized for storing and querying graph. It supports various graph queries and analysis such as graph traversal, pattern matching, shortest path, page rank, etc. So it is well suited for the use cases such as recommendation engines, fraud detections, knowledge graphs, social networks, where complex relationships and connectivity between the data are critical. So these are all the database services that we have on AWS. But for the scope of this particular course, we would be discussing about RDS, we would be discussing about Aurora, we would be discussing about DynamoDB, and that's it, guys. So let us now discuss about the relational versus non-relational databases. So we know that the relational database is the traditional database in which we generally imagine our databases, right? Where the data is stored in a structured way into tables which consist of rows and columns. So generally we think of database, whenever we talk about database, we talk about, we think about the tables, right? And SQL is a quite famous language, that is structured query language, which is used to manipulate and query the data which is being stored. If you want to retrieve the data, if you want to insert the data, manipulate the data, that can be done with the help of SQL queries. On contrary, when we talk about non-relational databases or NoSQL databases, we store data in more flexible and unstructured manner. So as I already told you about the semi-structured data, right? The data which is in the key value pairs or in the JSON documents or in the form of graphs. So those data or that kind of data is called as semi-structured data, and we store that data into NoSQL databases instead of table. So when we try to think about graph, it would be more of, nodes and edges. When we think about document, it would be more like the JSON document. Not only this difference, if we talk even about the schema, then the relational database is having a fixed schema with predefined columns and the data types. But non-relational databases has a flexible schema that allows for dynamic data structures as well. Relational schema or relational databases are generally used when you want to store, highly structured data where consistency is being required, such as financial data, customer information, inventory records, right? So in that case, we will store the data into the relational databases because that follows ACID transactions. That is, it provides us with atomicity, consistency, isolation, and durability, due to which our data would be always into the consistent form. Now, that is not always the case for NoSQL database. It may or may not support ACID transactions, but it often provides us with eventual consistency. Eventually, we would be getting the consistency, but the ACID transactions are not supported. And that too, many databases do also support the ACID transaction. So, NoSQL database is generally recommended when we want to store high volumes of data that may be unstructured or semi structured or would be having varying data types. So, at that time, we go with NoSQL databases, which are often used for big data application, real time web applications, or social media platforms, gaming, IoTs, right? These are some of the applications where NoSQL are much suited. So the AWS service for relational database that we'll be talking about is RDS. An AWS service for non-relational database can be DynamoDB, Neptune, then we had DocumentDB. All of these are the examples of non-relational databases on AWS. The next topic that we are going to talk about is unmanaged and managed database services. Okay, so here AWS provides us with both managed and unmanaged database services, which will differ in the level of control. Okay, level of control and the responsibility that a user has. Okay, over the database environment. So, on the basis of these two things, you should be deciding whether you want to go with managed or unmanaged service. So, when you go with the managed service, then the level of control is reduced. Okay, here we are talking about managed database service. So, the level of control that you may have on your database would be less, and the responsibility will also be less. If we talk about unmanaged service, then on the unmanaged service side as well, the level of control that you have on the database, okay, would be high, and the responsibility of yours would also be high. So I have this particular diagram with me. Let us try to understand that what this diagram is trying to tell us. So one is EC2. Okay, when we talk about unmanaged database service, so we can set up and operate our database on EC2 instance. So user is responsible for all the aspects of database environments. Example over here is anything that you see in orange color is AWS managed. So when we talk about power, network, hardware cycle, server maintenance, OS installation, all of that would be responsibility of AWS when we talk about database on EC2. But apart from that, operating system patching, database installation, configuration, maintenance, security, backup, maintaining the availability of the database, scaling, DBA duties, all of that would be your responsibility. So you see over here, the overhead of the responsibility is high when you are using the unmanaged database service. So you can include, you can install any of the database on your EC2 and it will work fine. Now, on the contrary, when we use the managed service, the managed service is fully managed, scalable, highly available database solution which is being provided to us by AWS. So AWS will be maintaining the underlying architecture, infrastructure, database configuration, all the maintenance tasks such as database backup, maintaining its availability, scaling, recovery, patching, upgrades. Everything would be responsibility of AWS. Now, what you need to manage? You just have to do your DBA duties. So, you have to manage your database schema, your data, access control. That's it. So, the operational overhead or the responsibility over here is reducing. And that's why when we discussed about different AWS databases that are being provided to us, I was always, emphasizing on the word managed, because all the database services that we discussed in previous slide were managed database services like RDS, DynamoDB, Neptune. All of these are managed database service. So the main advantage of using this managed database service is that it reduces the operational burden and the complexity of managing a database environment and provides high availability and scalability out of the box. It allows users to just focus on their application and data rather than infrastructure management. However, because we are having all such upsides, right, all such advantages, there would be some downsides. So, the downside may be that you have to face the higher cost and you will have limited control over underlying infrastructure of your database. So if you think that your application or your workload can handle this, okay, if you do not have such a strict budget constraints, then you can always go with the managed service.